Okay, styzor. First of all, hear that sound? You made a crack about that. Uh, those are frogs. That's what I was talking about. Those are frogs. Now here we are at the website that you showed us. Remember, there's the black core of the sun. It's called FuseEd Web. You said it wasn't lnl.gov. It was some education site. It's, excuse me, hello, here at the top, the URL. See that URL? llnl.gov. You know where that is? You know what that is? Well, you just scroll down to the bottom of the page. That's Lawrence Livermore National Laboratory. Now let's move up here to where it's talking about the temperature of the sun, the photosphere, the part that emits the light that we see. All right. Zoom in here. You will see. Do you see? Can you see this? Look. 6,000 degrees Kelvin. All right, 6,000 degrees Kelvin. Let's go over to this website. This is at NASA. This is, well, it's not at NASA, it's at Harvard, but it's a NASA project. As you can see, Smithsonian NASA Astrophysics Data System. This is on the temperature distribution inside, oh, what is it? Inside a cigarette. Here, look. You see? Temperature distribution inside a burning cigarette. Okay. It is 8 to 900 degrees Celsius during a puff. Now you know, no doubt, of course, that you can add 273 degrees to get the Kelvin, right? So it's about 1,000 to 1,200 degrees Kelvin in your cigarette during a puff. Back here, look, 6,000 on the surface of the sun. 6,000 degrees Kelvin, right? Photosphere. All right, let's go down here to this part. This is the page you are showing me, the words in it. Right, here's the picture up here. See, I'm not screwing with. Oh, that's the one with the white core. Sorry, there's the black core, proving it's black. Okay, now down the fuck here to your sunspots. Sunspots. Look, 4,500 degrees Kelvin. 4,500 degrees Kelvin, as opposed to 6,000. So like 25% cooler. Okay, back over here. 800 to 900 degrees Celsius during a puff. During a puff. $4,500 degrees Kelvin to 6,000 in the photosphere, with 4,500 being the sunspot temperature. Now, how the hell am I supposed to expect you to believe? Expect. How am I supposed to believe that you are reading these things and learning from them? That's 45. That's a higher temperature. It's a higher temperature. It's a higher temperature in the photosphere than your cigarette. What else is there? You think you schooled me? There it is right there. That's the temperature of your cigarette. It's also 4,500 degrees Kelvin. Do you know that that's hot? That things that hot glow in optical wavelengths? Now, I don't really care about whether you want to call X-rays black as a description. fine. Doesn't really matter because the sun is not just producing X-rays. It's producing light in a wide variety of spectrums as a black body. I didn't search this one ahead of time. Let's just type in black body and see how hard it is. Okay, Wikipedia. I'll bet it has a graph for you. Oh, wrong thing. Let's try again. Black body radiation. See that? Let's just zoom in on what black body radiation is. Right? Those are frogs you hear. Okay, the intensity of the radiation versus the wavelength, and it's dependent on the goddamn temperature. See this here, this green line, that's at 4,000 degrees Kelvin. See these? Most of the light is in the optical. Most of the light's in the optical. See that? See the blue one? That's the 6,000 K. So that's a sunspot. You see how the cooler it gets, the less light it produces. 4,000 K produces more than 3,000. And they haven't drawn it on here, but that produces more than 1,200 degrees Kelvin. It's not just X-rays. It's not just one wavelength. No, it's producing shitloads of optical light at 4,000 degrees Kelvin. Let's just remind you. Back over here. That sunspots are 4,500 degrees Kelvin. Alright? Alright, now I'm being kind to you. I'm giving you the benefit of the doubt. I don't waste my time trying to go around find idiots online. I got in with you because I thought, hey, he likes Monty Python. Read a lot of physics. He might have missed some facts, but he won't be this obtuse. But you are. But maybe you still want to learn. Maybe you just have trouble admitting when you made a mistake, or heard somebody at a party tell you some little counterintuitive fact, which also turned out to be counterfactual. Okay, now if you can't face these facts, then you have a serious problem, because we're not talking about confusing things at the center of the sun, which you are totally ill-equipped to consider. We're talking about things in the surface of the sun, the part we can see. 4,500 degrees Kelvin. Okay, that's more than 1,100 degrees Kelvin. 1,100 degrees Kelvin, that's your cigarette. Okay, 4,500, that's a sunspot. 6,000, that's the photosphere, as compared to the photosphere at 6,000 Kelvin. So you understand that yet? So you want to say, oh, but it's just a proven fact, but with no citation. And this is on the page you gave, which, yes, was at a .gov site. See this picture? See this picture? Look at this one. See this picture? It's a picture of the sun and X-ray. See those dark spots? They're not really black. That's just where there's not much X-rays. And there actually are X-rays coming out of there. But at the scale of this picture, what you call the stretch of this picture, they look dark. The picture is scaled so that they look dark, so that they stand out, so you can see the cooler regions. Now, it's not my fault. It's not my fault, except for that I believed you really did have a looking into physics hobby. Okay, that's my fault. Taking you seriously, giving you the benefit of the doubt, trying to discuss this stuff with you. Now,